Hello, Dr. Mandy here from Real Good AI, and I think I'll talk to you today maybe a negative. Let's talk about why Gaussian process models aren't already adopted. It's not that neural network people are like, no, I like the black box. Go away, anyone trying to fix it. No, there are actually some major scientific challenges that are roadblocks, honestly. And if you're not sure that they will break through, I can see why you would never go down the path of Gaussian process models. So let's talk about it. The first issue is computational infeasibility. And now, when I'm saying this, I don't mean like let's just put it on a supercomputer for more time. We just need more energy to make this work. The usual issue with Gaussian process models has historically been memory, meaning that I actually can't store the thing I need to compute to do it, which no amount of supercomputer in the way that they're built now really will help that problem. It's not a time issue, it's a memory issue. And so I've spent maybe the last 6, 7 years. Oh, that's not even right because I got to include my PhD. I spent maybe the past 10 years working on that problem, where now we can take a lot of observations in with Gaussian process models. And I feel relatively satisfied with the solution we came to. And the solution is called MyGPs, MUYGPS. If you want to look more into it, we have a few papers on it. But the important part here is that we break this apart so it's no longer this big memory issue. We need to solve a bunch of small problems instead of a big problem. And the computational efficiency and the memory efficiency is huge here. I mean, huge. Something that you couldn't do before, and now you can do in seconds. Like, it's crazy. So I'm really happy with that solution, and I think that it's not well known yet. I think it's relatively still under wraps. And whenever people try and fit Gaussian process models, I still hear, oh, but I can't do this, and it's because they're doing something really silly. So I guess misunderstanding about the models would be number two, in that you have to have an expert to fit them. They're not neural networks. They're not black boxes where it will just do everything for you. You need to actually have some modeling knowledge to be able to fit them. And there are not enough of us who know about Gaussian process models for this to be everywhere yet. And I mean, all the secrets. And really, the funny part is the secrets aren't even well written down. They're like passed down from advisor to student, advisor to student. Like all the secret back of the book answers, they never write in a book, which is so silly. I'll tell you all those things, by the way. Anyway, so number two is maybe knowledge. And the third issue is sort of flexibility in these models. Now, by design, you have to make some assumptions about your model so that you can do something, right? Like that's how we get structure in the model. But Gaussian process models tend to assume things that are close, very correlated. Things that are far away, not so correlated. Okay, but that might not always be true. Think about a wave here, right? So things may be far away in the wave, but close together in similarity. Like we're seeing the same thing repeating. Okay, so we want to be able to understand and learn those patterns, those inconsistencies, and things that can happen. And Gaussian process models are not flexible enough to do this in their inherent state. So we're going to keep working this next year. And I just thought I'd tell you that neural network people are not bad people at all. There are these major issues. I just truly believe that there are solutions to these problems, and we're going to be able to move forward with Gaussian process models where they don't belong.